Hey everyone, let's build our foundation for what the structure of an atom really looks like. And a lot of this may well be review for you. Some of it may be a little bit new, and then will serve as a foundation for what we do moving forward. So our very basic rudimentary structure of an atom is that we have this tiny yet very massive positively charged nucleus in the middle, and then we have electrons that are negatively charged somewhere in the area around the nucleus. And to get a size of just how small that nucleus is, imagine that the nucleus is the size of just like a grape. The electrons would be about a mile away. So that is a really, really large area, right? And so we know that atoms are really, really tiny. So if we shrink that down to atomic size, think how much that shrinks that nucleus down. It was the size of a grape, and now we're shrinking it that much, so it's got to be really, really darn tiny. So let's define those two regions of the atom. In the nucleus, that is where we find most of the mass of the atom, and we'll actually assign some numbers to this in a minute. That is where we find the protons. Protons are positively charged. Neutrons are neutrally charged. They don't have a charge. And then somewhere around that nucleus is something we call the electron cloud. The electron cloud has the electrons. The electrons are negative. Now, the electrons are very important for determining what the chemical properties of the element actually are and how it might bond. So you have this table on your note guide, and it turns out that electrons and protons and neutrons are really, really darn small, right? And they're really small, and that means they're really light. So over here, you see their mass. And their mass, notice, is 10 to the negative 24th power, or 10 to the negative 28th power. So it's really, really small. And so a while back, people got together and said, hey, we don't really want to write that number out over and over and over again. It's just kind of too small to comprehend. So let's approximate that. Let's approximate that to a value. In fact, we're going to make protons and neutrons, because you can see here that they're almost the exact same mass. We're going to give them both the same mass, and we're just going to call it 1. Right? And so we have this new unit called AMU. AMU stands for atomic mass unit. And we would say that a proton has a mass of 1 atomic mass unit, and a neutron has a mass of 1 atomic mass unit. So the important part there is protons and neutrons, they're in the nucleus, and they both weigh about the same amount. Electrons, yes, they are there. Yes, they are a thing. Yes, they have mass. And you'll notice here that the mass of an electron is really, really small. And in fact, it's times 10 to the negative 28th power, while this one is times 10 to the negative 24th power. So even though electrons have mass, you'll notice that they are 10,000 times lighter than a proton and a neutron. So because they're 10,000 times lighter, in the AMU scale, we actually assign electrons a mass of 0 because they're so insignificant as compared to protons and neutrons. They don't really affect the mass of the atom all that much at all. And just so you know what an AMU actually represents, an AMU is equal to this number, 1.660540 times 10 to the negative 27th kilograms. In other words, it's really, really light, right? And then the final thing to notice over here is the charge. And what's cool is that you'll notice that the charge of a proton and the charge of an electron are equal, but their signs are opposite, which means if you have equal numbers of protons and electrons, electrons are negative and protons are positive. If you have equal number of positive protons and negative electrons and they have the same charge, just opposite as we see here, that means that the overall atom is neutral. So let's get some practice in, and we are going to do all of these practice problems in units of AMU. So just keep that in mind as you're doing these practice problems. If you'd like to pause and go ahead, try it. Hopefully you've had a chance to pause, and we'll come back. So the mass of a proton is 1 atomic mass unit. The mass of a neutron, 1 atomic mass unit. The mass of an electron, even though this seems crazy, 0 AMU. We have an uncharged particle in the nucleus. What the heck is it? Well, it's a neutron. Right, so neutron, a lot of people think the N means negative, but think more neutral, right? So that means neutral, no charge. Which particle makes the greatest contribution to the mass of the atom in AMU? Where is it? Well, there are 2 of them, right? Protons and neutrons both contribute to the mass of an atom, and they are located in that small central region called the nucleus. Remember, the nucleus is made up of positive protons and neutral neutrons, which means that this thing overall positive plus 0, this thing is positive, which actually brings up a really interesting question, right? So if we have this nucleus made up of positive protons and neutral neutrons, what keeps it together? If you have a whole bunch of positive things next to each other, don't they want to repel? And so there's actually a force that we're going to talk about a little bit down the road called the strong nuclear force. So the strong nuclear force is this force of attraction, and it basically overcomes this electrostatic repulsion between these positive charges. And the fact that it can overcome that repulsion means that they are able to stick together. But again, we'll talk more about the strong nuclear force down the road. And then your final practice problem, which one is the greatest contributor to chemical properties? Well, that's the electron, and those electrons